All right, welcome back. We are still in Unit 1, but we are skipping some lessons. Last lesson was Lesson 5. We are going to move forward to Lesson 10. This lesson talks about the effect of extremes, or outliers. We briefly mentioned some of what we're going to cover today in Lesson 5. Today, we're going to take a deeper look at how extremes, or outliers, affect our measures of center and help determine which measure of center we should use, and in turn, which measure of variability we're going to use. So today's lesson says, let's see how statistics change with the data. So here they give an example. It's a dot plot, time to hit dartboard in seconds. So our low is at 1 second, our max is at 1.8 seconds. We have a bell-shaped symmetrical dot plot here. So we're going to look at how the shape of distributions affect what measures we should calculate and use when we're reporting these statistics. All right. Our learning targets, these are the important skills that you want to be able to walk away from this lesson and confidently say, you can do these two things. So if at the end of class, you can go back to these learning targets and say, I can do these, then this has been a successful lesson and you are good to move forward. If you look at these learning targets at the end of the lesson and you're still a little unsure about your ability to complete them, ask me questions, ask your classmates questions, and let's make sure that we have this skill honed in, ready to go for when we get to the end of unit test. So the learning targets here, I can describe how an extreme value will affect the mean and the median. So we're going to look at these extremes, extremely low, extremely high, and we're going to see, do they affect the mean or the median and how? And then the second learning target, I can use the shape of a distribution to compare the mean and the median. So we're going to talk about how the shape does or does not affect the mean and the median, and how we can simply look at the shape and understand whether they're going to be the same or whether one is going to be higher or lower, and how we know which one that is. Again, these skills are absolutely going to be tested on the end of unit assessment, so we need to make sure that you are comfortable saying you can do both of these learning targets. We'll start up with our warm-up. It says we should take about 10 minutes. This one is called Battle Royale. This is available on Kim as well as in the workbooks, so you're welcome to do either one, or maybe just work on a piece of paper at your desk, or go up to one of the whiteboards and work as a group, whatever you're comfortable with. But it says the Battle Royale, several video games are based on a genre called Battle Royale, in which 100 players are on an island and they fight until only one player remains and is crowned the winner. This type of game can often be played in solo mode, as individuals, or in team mode in groups of 2. So the first question asks, what information would you use to determine the top players in each mode, solo and team? And explain your reasoning. So take a minute to think about this question on your own, and then talk to those around you. There could be different ways to define who the winner is based off of what you believe is most important. So see if you and those around you come up with the same way of looking at who the winner should be, or whether you have different opinions on who the winner should be. And question 2, one person claims that the best solo player play game A, another person claims that game B has better solo players, how could you display data to help inform their discussion and explain your reasoning? So in the first one, you're thinking about what quality are we looking for that determines who should win. But in number two, you're saying in a make-believe scenario where you have game one or game A and game B, what kind of data that we've talked about could you make a visual display of that would allow them to come to a conclusion as to which game they think has better players? So think about what stats you and your group decided were the most important, and then think about how you could display those stats for two different games in order to compare them and decide which game had better solo players. Okay, so they're giving us a 10-minute time limit. Take 2 minutes to think about each of these questions, how you yourself would answer them. Then spend 5 minutes working together with those around you and see if you can come up with what statistics should determine who the better player is, and then how you could create visual displays of those statistics in order to compare the games and definitively come up with your opinion on which game was better. And then about the last 3 minutes, we'll come back together and we'll go over it as a class, and we'll see what kind of different ideas the class had in regards to what makes someone a better player, and then what ideas the class had on how you could create visual displays to help support your argument. So go ahead and pause the video, work on these, and then we'll come back together. Okay, for anybody watching at home, for number one, what information would you use to determine the top players in each mode? So there's different trains of thought on this. Now, if the goal is to be the one remaining player, then the best player, it could be argued, is the person who manages to be that last survivor the most often. So victories in this game mode would be one way that somebody could say they are the better player. However, that also allows someone to have a strategy where they spend the majority of the game hiding, come out at the very end, manage to defeat the one remaining person in the game, and then be declared the winner. Other people might look at this and say that the winning player, even though the end goal is to be the last remaining player, some people believe the better player is the person who beats the most other players. So we have two different trains of thought here. So whatever group you might have been a part of in the class, these are two competing thoughts that they could have had, or possibly come up with even more ways to decide who the better player is. Number two, one person claims that the best solo players play game A, and another claims that game B has better solo players. How could you display data to help inform their discussion? So we have talked about two different types of statistics. We've talked about measures of center, whether that's mean or median, and we've talked about measures of variability, whether that is interquartile range or whether that is mean absolute deviation. Depending on which statistic you wanted to use, you could create some type of visual display, whether that be a dot plot, a histogram, or a box plot. And then you could compare the value of the measure of center. You could compare the mean or the median and see which one is higher and say that the game who has the higher average player has the better players. Or you might say, the second game has a better average player, but their results are widely varied. They have a large IQR, whereas game A might have a slightly lower average player, but most of their players are tightly packed around that. So you might say the game that has a better measure of variability would be the better one. Or you might specifically look at who has the better best player. So you look for that maximum value in whichever stat you chose and compare just the maximums to each other. You might compare the minimums. You might say one game's worst player is better than the worst player in the other game, therefore the first game has it. There's a lot of different ways that you can present statistics. When I teach statistics as a class, I often tell my students that the greatest thing and the worst thing about statistics is that I can make them say anything I want and I don't have to lie. It's a matter of which statistics you use and how well you present them to promote your side of the argument in a case. So regardless of how you decided to pick a statistic and present it, I wouldn't say there is a correct answer. I would say, did you argue your case correctly in how you presented which one you chose and why you think that determines one is better than the other? So that's one thing to keep in mind about statistics. Okay, we'll move on to activity 10.2. This one should take about 15 minutes. This one is titled Separated by Skew. Again, this is available on Kitum or in the workbook, or feel free to just work on one of the whiteboards in class as we work our way through this. If you are doing this online through Kitum, you're going to see an applet that looks like this. What it allows you to do is enter in all of the data points that they give you, and then have the applet create your visual display. So you could click on dot plot, it would take the values that you typed into the data box, and it would plot all the points on there for you. Then you can also tell it to plot the mean, you can tell it to plot the median, and you can tell it to show the statistics, and it will show you the actual numbers for each of those. So this is a tool you can use on the Kitum website that will allow you to just type in all the numbers from your data set, have it create your dot plot for you, have it tell you where the mean and where the median are so that you can compare them with each other. So the first thing they want you to do is use the applet to create a dot plot that represents the distribution of the data, then describe the shape of the distribution. Then they want you to find the mean and the median of the data. So again, if you're using the applet, you can have it plot the mean and the median and then show you what they are. So you can just type the data right into there. And that would be these numbers right here that are given to you in the workbook or online. Now it says, find the mean and median of the data with two additional values included as described. So if you are using the applet online, all you need to do is go add numbers into this box here, and then it will add them in the dot plot, and it will recalculate your statistics for you. So first, they want you to add two values to the original data set that are greater than 14. and see what happens. You want to write the mean and the median in here. For the next one, they want you to add two values to the original data set that are less than 6 and see what happens. Then they want you to add one value that is greater than 14 and one value that is less than 6 to the original data set and see what happens. And add the two values 50 and 100 to the original data set and see what happens. So in all of these, you're going to follow their directions and you're going to write down what is the mean and what is the median so that you can see how these are affected anytime you change. To finish up here, it says share your work with your group. What do you notice is happening with the mean and the median based on the additional values? Change the values so that the distribution fits the description given to you by your teacher. Then find the mean and median. If you are here in class, these are going to be given to you. So the first choice is that you're going to make a uniform distribution with data between 4 and 12. The second option is that it's going to be skewed right with most of the values at 10. The third option is that it's going to be skewed left with most of the values at 10. And the fourth option is that it's going to be symmetric with most of the values at 4 and 16. So if you're in class, I'm going to write these on the board. If you're watching outside of the class, these 4 descriptions at the bottom of the PowerPoint here are the ones they are referring to. So change the values so that the distribution fits one of those descriptions. And then find the mean and the median. And number 4, find another group that created a distribution with a different description. So you pick one of those 4, you find the mean and the median once you make it fit that description, then find another group who chose a different one out of those 4 and compare your work with each other. Explain your work and listen to their explanation and then compare your measures of center. So for this one, it says take about 15 minutes. So with your group, work for about 10 minutes. Then we'll come together the last 5 minutes and we'll go over this so that everyone understands what we're doing. And then we'll move on to the next activity. So if you're in class, go ahead and pause the video here, get with a group, work through this, and then we'll come together. Okay, so if you're watching this online, let's work through some of this and see what it is that we're trying to understand. The first thing they want us to do is create a dot plot that represents the distribution of the data and then describe the shape. So if we look at the screen right here, we can see our data is right here. And if we're creating a dot plot, we're going to put 1 dot every time a value shows up. So we have 1, 6, 1, 7, 2 8s, 3 9s, 4 10s, 3 11s, 2 12s, a 13, and a 14. So this is what our dot plot would look like. Now, if we were to describe this, they're looking for us to use those 5 terms we've been looking at. So the first one is bell-shaped, and that would apply to this. This looks like our data is in the center. It slopes away to the left and the right at about the same rate. So we would say that this is bell-shaped. Now, if we go back, our next one is bimodal, 2 peaks. We do not see 2 peaks. We see 1, so it's not bimodal. Then we have skewed, which means most of our data is to one side or the other with a tail. That does not fit this one, so this would not be skewed. Then we have symmetrical. Symmetrical means if I folded this data set in half, the sides would match up. This bell-shaped data distribution is also symmetrical. So we can say that this is bell-shaped and symmetrical. And then the last one we talk about is uniform. Uniform means it's about the same height all the way across. That does not fit this, so this would not be uniform. The next thing they want us to do is find the mean and the median. So if you're doing this in the Kitim website, you can click these boxes and it will calculate them for you. But on here, the first one we can do is the median. Remember that the median is the middle point. So here, as we look, we've got 1, 1, 2, 3 from the left. We've got 1, 1, 2, 3 from the right. So our middle value is going to be the middle of this stack of 4 on 10. So that means our median is going to be right here. Half of my dots are to the left, half of my dots are to the right. My median divides it in half. So my median is 10. In order to find the mean, we need to add them all together and then divide by how many there are. So in this case, we're going to add all of these numbers together. And we get a sum of 180. So we can say 180, and we're going to divide that by how many points we have. We have 18. So over here we have 180 divided by 18, and that is going to equal 10, which is our mean. So we had bell-shaped symmetrical data, and we ended up with a median and a mean that were both 10. Now they want us to add 2 values to the original data set that are greater than 14 and see what happens. So if we did that, Let's go in here and we will add two values that are greater than 14. We'll say 15 and 16. Now I have two extra points on this side, so I have 11 to the right and I only have 9 to the left. So I'm going to need to move my median to right here. Now I have 10 dots to the left, I have 10 dots to the right, but my median is still 10. Nothing changed. But now instead of having 180 when I add my 10 dots together, I'm going to have 180 plus 15 plus 16, and that gives me a total of 211. And instead of having 18 points, we now have 20. So we divide by 20. 211 divided by 20 equals 10.55. So notice when I add more values to the right or to the higher end, now we would say that this is skewed because most of our data is to the left and we have a longer tail out to the right. So we would say that skewed right means the median or the mean is greater. The mean followed the outliers. The added points to the right pulled that mean with them. So if you have skewed right data distribution, your mean is also going to move to the right some. That is going to mean that your mean is greater than your median. So if you have skewed right, then your mean is greater than your median. Next, they want us to add two values to the original data set that are less than 6. So now we'll do this in blue, and we'll say we do 5, and we'll put one down here at 4. And we're not going to count the red dots anymore. We're adding these lower values to the original data set. So now we would say that we have skewed left because our data or our tail is to the left. So now we have skewed left we now have more points to the left. So instead of our median moving 1 point to the right, our median is going to move 1 point to the left, but it still ends up being 10. So our median has not changed. So for skewed left, my median still equals 10. When we calculate our mean, we had 180 for our original total. So now we're going to say 180 plus 5 plus 4. and we get 189. We still have 20 points. So 189 divided by 20 equals 9.45. So again, the direction that we added the extra points to is also the direction that our mean traveled. Our mean follows those additional points. So when we had skewed right, the mean is greater than the median, but when we have skewed left, the mean is less than the median. So that is a very important fact to keep straight because it will show up on your end of unit assessment. You need to understand that if you have skewed data, then your mean is going to follow the tail. So if your tail is to the left, then your mean is going to follow that tail to the left, and it's going to be less than your median. If you have skewed right data, because you have a tail to the right, your mean is going to follow that tail, and your mean is going to get larger than your median. But this also shows why we use mean only when we have symmetrical data. Because if I have skewed data, it's going to move that mean, and it's no longer going to give me an accurate representation of where the center of my data is. Now for this one, they ask us to add one value that is greater than 14 and one value that is less than 6 to the original data set. So we can come up here. Let's make this orange. So we're only paying attention to the green and then the orange that we add. So let's say we add 1 dot at 15 and 1 dot at 5. Well, now my median is going to stay the same because I now have 10 points to the left and 10 points to the right. So my median has not changed. It's still right here. It's still 10. So I would say I still have bell-shaped and it's symmetrical. And my median is still 10. And then we would take our original 180, we would add 5 and 15, and this becomes 200. We have 20 points, so 200 divided by 20 equals 10. And you notice, because this is still bell-shaped and it is still symmetrical, then my mean and my median have not changed. This is an important point. If you have symmetrical data, then your mean and your median will be the same. And the last thing they want us to do here is add two extreme outliers, 50 and 100. So if I make these in purple, we're only looking at the green points and the purple points. And we're going to say we're going to put one way out here at 50, and we're going to put one way out here at 100. So now we clearly have skewed right data because our outliers, our tail, is to the right. So we're going to say skewed right. My median, because I added 2 points to the right, is only going to move 1 point. So instead of it being here where the green and orange are, it's going to be here, the same spot the red was. But my median is still 10. It hasn't changed. However, when I add these points to my original 180, 180 plus 100 is 280. 280 plus 50 is 330. So when I'm calculating my mean, I now have 330 divided by the 20 points, and that equals 16.5. So now you can see that extreme outliers pull the mean towards them. And the more extreme they are, the more it's going to move that mean. So skewed right, your mean is greater than your median. So you need to remember, we only use mean when it is symmetrical data because your mean and your median will be the same when it's symmetrical. If we have skewed data, then the mean is going to follow your tail. So if it is skewed right, your mean gets bigger and your mean is bigger than your median. If you have skewed left, then your mean gets smaller and your mean is less than your median if you have skewed left. So make sure you're comfortable understanding how this gets affected because it will be on your end of unit assessment. So now if you were in class, you could share your work with another group. What do you notice is happening with the mean and the median based on the additional values? You should notice that as long as you have symmetrical data, your mean equals your median. But if you have skewed data, you should notice that your mean follows the tail. So if your tail is to the right, then your mean is bigger than your median. And if your tail is to the left, then your mean follows to the left and it becomes smaller than your median. The values where you chose a description, hopefully when you compared these with other groups, you will have seen this same trend. And then finally, find another group that created a distribution with a different description, explain your work and listen to theirs. Then compare your measures of center. Hopefully you were able to see more examples of what we showed going through this. Symmetrical data will result in your mean and your median being the same value. Skewed data will result in your mean following the tail. So if it's skewed right, your mean goes to the right and gets bigger than your median. If your data becomes skewed left, the mean follows to the left and gets smaller and becomes less than your median. Those are the important takeaways from this activity. So our next activity should take about 10 minutes. It's called Plots Matching Measures. It is available in Kidam if you would like to do it there. This one says create a possible dot plot with at least 10 values for each of the conditions listed. Each dot plot must have at least 3 values that are different. So the first one that you are going to create is a dot plot that has your mean and your median both at 10. You need to have at least 10 dots, and at least 3 of those dots must have different values. For the second one, you're going to create a dot plot where the distribution has both the mean and the median at -15. Again, you must have at least 10 dots, and at least 3 of the dots must have different values. Third, create a dot plot with a distribution that has a median of 2.5 and a mean greater than the median. So create a dot plot, at least 10 points, and at least 3 of those points must have different values. Number 4, create a dot plot with a distribution that has a median of 5 and a median that is greater than the mean. Again, at least 10 points, and 3 of those points at least must have different values. So, if you're in class, let's take 5 minutes to work in your group, and then we'll come together as a class and we will discuss what these distributions would need to look like. Okay, so if you're in class, go ahead and pause it here, get with your group, try to work through this activity, and then come back. All right, if you are at home watching this, let's go through and describe what each one would have to look like in order to fit these descriptions. So for number 1, it says they want a distribution that has both mean and median of 10. So this would mean if they are the same, it must be symmetrical. Now this could be bell-shaped, it could be uniform, it could be bimodal, but the important part is that it must be symmetrical. And it must be symmetrical with a center at 10. If you draw a symmetrical distribution, regardless of whether it's bell-shaped, bimodal, or uniform, and that symmetrical data is centered around 10, it will fit this description. For number 2, again, we want the mean and the median to be the same, but instead of being centered around 10, we want to center it around -15. So again, it must be symmetrical. And it must be centered around -15. It could be bell-shaped, it could be bimodal, it could be uniform, as long as it is symmetrical. The fact that it's symmetrical will make the mean and the median be the same. And if I want those to both be -15, then I need my center of the distribution to be at -15. Our third one, we want a distribution that has a median of 2.5 and a mean that is greater than the median. In order for them to not be the same, then we know this must be skewed. And if I want the mean to be greater, it must follow a tail to the right. That will cause the mean to follow the tail into bigger and bigger numbers. So we want skewed right. And this will cause the mean to be greater than the median. And I need my center to be at 2.5. So as long as you drew something that was skewed right, meaning the tail goes to the right, and your center point is at 2.5, it'll match this description. And lastly, we want a distribution with a median of 5 and a median that is greater than the mean. So again, for them to not be the same, this must be skewed. And for the median to be greater than the mean must follow the tail to the left. So this must be skewed left data. We want center point at 5, and this creates a mean that is less than the median. Okay, so now to wrap up, they ask the question, for the first and second dot plot, what do the distribution shapes have in common? These were the distribution shapes where our mean and our median were the same. And what they share is that they're both symmetrical. So anytime we have symmetrical shape, our mean equals our median. And why do we choose the mean as the more appropriate measure of center? Well, the mean takes all our points, adds them together, and divides by how many there are. If it's symmetrical, then our mean will give us the exact average, whereas our median will give us the value of the center point. Okay? So our mean is more accurate. Next it asks, what do the shapes of the dot plots have in common when the mean is greater than, this should say, median? So when the mean is greater than the median, that means we have skewed right shape, because the mean will always follow the tail. So in order for the mean to get bigger, it needs to follow the tail to the right. What information does the shape of the skewed distribution tell you about the median and mean? So the tail tells you which direction So if the mean moves left, then the mean is less than the median. If the mean moves right, then the mean is greater than the median. So the direction of the tail tells you which way the mean moves, and that tells you which one is greater. So to sum up this activity, why is the median preferred to the mean for skewed data? Because the median doesn't move as much. Okay? If it might move one spot to the left or one spot to the right, but it doesn't move as much. The mean follows the tail, and the more extreme an outlier is, the more the mean moves. So the median is preferred because the median doesn't change as much. Next, when an extreme value is present, why is the median preferred to the mean? Again, the median is not affected as much. It does not move as much. And finally, when data is symmetric or approximately symmetric, why is the mean preferred to the median? Because they will be about the same, but the mean is going to give us a more accurate value because we actually add them all together and divide. So we're going to get a more accurate measurement. So those are the important things to take away from this activity. The mean follows the tail of skewed data. So as long as it's symmetric, we use mean and mean absolute deviation. But if it is skewed, then we must use median and we must use interquartile range. This distinction will be tested on your end of unit assessment. So make sure you are comfortable with these concepts. So now we will finish up with the cool down. Remember that cooldowns must be completed on the KITM website, and cooldowns are individual. This is not to be done in a group. This is for me and the district to get a better idea of how well you are retaining the information from this lesson and the previous lessons as we move toward your end of unit assessment. So log into your KITM account if you're not there already. Go to Cooldown 10.4, Shapes and Statistics. Part A asks you about the distribution at the top. Is the mean greater than, less than, or equal to the median? So think about what shape does this dot plot have? Is it symmetrical or is it skewed? And based off of that, answer the question. And part B wants you to actually explain your reasoning. So just type in there. The shape is this. That means this is what I know about the mean and the median. As far as glossary terms go, for this lesson, we only have one term, and that is statistic. A statistic is a quantity that is calculated from simple data such as mean, median, or mean absolute deviation. Anytime we calculate one of these, we are calculating a statistic. So make sure you understand what a statistic is going forward. If you are in class, thank you for your participation. If you were absent and you came online, thank you for taking the time to come online, make sure you understood what we were doing so that when you come back to class, you'll be on the same page as everybody else. And if you're just going back to rewatch this, thank you for the dedication to making sure that you understand this material. And I will see you in the next class. Thank you.